The object that swept across the stars above Mars in October of 2025 was destined to be remembered, and for anyone following the mystery, the invitation was clear. Read on. Because the story of 3I Atlas may reshape how humanity understands its place in the cosmos. Yet the form in which this strange visitor imprinted itself on history was not the one scientists had expected. Officially labeled Interstellar Visitor 3, or 3I Atlas, it represented only the third confirmed body known to have come from beyond the solar system. That fact alone should have secured its quiet place in astronomical archives. But from the very beginning, the data received by the Perseverance rover's night sky cameras did not resemble quiet archival material. They suggested disruption, inconsistency, and a set of puzzles that refused to be filed away under the categories of known natural behavior. What might have been celebrated as a straightforward encounter rapidly mutated into a crisis of interpretation, shaking the normally methodical scientific community out of its calm equilibrium. The decisive moment came when Perseverance captured an astonishing streak of light racing across the Martian night. Its measured speed was 60 kilometers per second, a value that aligned with uncanny precision to the forecasted velocity of 3I Atlas. The match between prediction and observation should have been a triumph, confirming the reliability of orbital models. Instead, it raised the unsettling possibility that something far stranger was underway, a moment that had been planned as a symbolic milestone in planetary science suddenly appeared to be the opening act of a deeper drama. Controllers on Earth had prepared themselves for disappointment. From the orbiters circling Mars, the spacecraft cameras, designed primarily for examining planetary surfaces, were never built to chase a dim, hyper-fast speck of light rushing through interplanetary space. A lack of images was expected and could easily have been explained. But what emerged instead were unconfirmed reports that refused to fit within those boundaries. Multiple objects were rumored. Bursts of velocity were whispered about. And above all, a particular kind of glow, a diffuse green luminescence, was claimed to have been present. A glow that resisted ready explanation. Early images collected far above the Martian terrain seemed to bear out the unsettling rumors. The trajectories were simply too fast, too smooth, and too stable to belong to meteors or satellites. Nor did the recorded signatures look like those of familiar comets. The visual data suggested something anomalous, and when institutions hesitated to offer interpretations, speculation flourished. The official channels slowed to a crawl, explanations were withheld, and in the vacuum of clarity, the scientific consensus began to fracture. The world's most prestigious research organizations appeared unable or unwilling to deliver answers precisely when those answers were demanded most urgently. Into this void stepped the amateur community, armed not with billion-dollar instruments but with persistence and transparency. On the 2nd of October 2025, a man named Stephen Burns, long respected in the small but dedicated world of independent astrometry, released a carefully constructed time-lapse built from the Perseverance raw image archive. His video, extending over 9 minutes and stitched from consecutive exposures, depicted a bright trace cutting low across the Martian sky. It was not noise, nor cosmic ray interference, nor a defective pixel. Its defining trait was its constancy, a sustained velocity of 60 kilometers per second that distinguished it decisively from the irregular flashes typically seen in raw space imagery. Burns did more than simply present a pretty sequence of images. He provided the methodology in painstaking detail. Each position had been mapped against known stellar catalogs, each interval carefully synchronized with spacecraft timestamps, each geometric correction applied with rigor. His conclusion was unambiguous, yet he did not insist on belief. Instead, he invited others to replicate or dismantle his claim. What followed was a wave of scrutiny. Thousands of independent analysts around the globe took up the challenge, and the overwhelming consensus was clear. The streak aligned with the projected path of 3I Atlas almost perfectly. This public confirmation placed immense pressure on official institutions, particularly because their own orbital platforms, MRO, TGO Mars Express, remained frustratingly silent. Efforts to image 3I Atlas at nearly 30 million kilometers distance represented a formidable geometrical challenge. Cameras engineered to stare downward at the Martian surface were forced to twist unnaturally, executing rapid slews that strained their operational design. The consequence was delay, Processing pipelines collapsed under the unusual requirements. Cosmic rays appeared like false fragments. Hot pixels masqueraded as objects, and the risk of releasing contaminated data grew severe. The result was paralysis. Agencies hesitated, preferring silence to error. But in the eyes of the public, that silence quickly transformed into suspicion. Was the data being refined too slowly or deliberately hidden? The problem deepened with the appearance of the green glow. Traditionally, such coloration in cometary observations is the universal fingerprint of diatomic carbon, C2, emitting bright green bands when energized by sunlight. If 3I Atlas displayed such emissions, it would be categorized as an active, volatile comet. Yet preliminary spectra suggested otherwise. Instruments aboard TGO and Mars Express indicated that the C2 bands were weak or even absent. Instead, the composition seemed richer in silicate material, heavier and more rock-like than the fluffy carbon-dominated ices that usually produce a glowing green veil. A contradiction emerged: a luminous green color without the corresponding carbon emissions. In laboratory terms, it was an impossibility. If the glow were genuine, then some new chemical mechanism, perhaps exotic silicon compounds interacting with the solar wind, would need to be invoked. If it were not genuine, then digital artifacts and calibration errors would have to shoulder the blame. In either case, the absence of a firmly time-locked, calibrated spectrum ensured that the mystery remained unresolved. And that unresolved state became the most compelling aspect of the object's story. Trajectory analysis added another layer of enigma. Typical comets, when active, betray their volatility through slight deviations from pure gravitational paths. Gas jets vent from their surfaces like miniature thrusters, imparting measurable non-gravitational accelerations. 3I Atlas, however, hugged its predicted track with surprising fidelity. It glowed, and yet it drifted not at all. Such silence in its dynamical behavior implied a body far denser and more compact than a conventional comet, perhaps weighing less than 10 million tons, but composed in a way that resisted typical outgassing. The possibility arose that the object was not simply a natural hybrid, but something stranger. If its motion were perfectly gravitational, despite evidence of activity, could that indicate deliberate micro-adjustments? Maneuvers too subtle to appear as bursts, yet effective in maintaining a controlled trajectory. Such an interpretation touched on the long-sought notion of techno-signatures, evidence of engineering rather than geology. Amid these growing uncertainties, a provocative voice entered the discussion. Avi Loeb, never a stranger to controversy, calculated that if one traced 3I Atlas's orbit backward across decades, there existed a small but tantalizing chance that it had passed through the coordinates of the celebrated 1977 WOW radio signal. His team's Monte Carlo simulations placed the probability at roughly 0.6%, low but not negligible. The coincidence between an interstellar body and the most famous unexplained radio detection in SETI history was enough, in his view, to demand close and immediate study. Critics argued that such reasoning risked falling into post hoc fallacy, that aligning an object with an event decades in the past proved little. Yet the suggestion carried weight in the public imagination. Might the passage of 3I Atlas now, visible and measurable, represent the continuation of a story that had begun nearly half a century earlier? Radio telescopes were called upon to search once more, to listen for echoes that might complete the arc of that earlier mystery. By late October, the debate was forced into suspension by the mechanics of the solar system itself. 3I Atlas slid behind the sun, concealed by conjunction, inaccessible to both Earth and Mars for several weeks. Astronomers dubbed the interval the November Blackout, a pause not of choice but of celestial geometry. The silence was inescapable. Attention shifted to the coming window in early December, when the object would re-emerge from the solar glare. That window, scientists agreed, would be decisive. Plans for that return were structured as a deliberate ladder of verification. First, replication. Would the high-speed streaks and the disputed green glow appear again, consistent across instruments and independent observers? Second, spectral fidelity. Could the glow be isolated and proven not to correspond to C2 emission, thereby confirming that the chemical anomaly was real and not an artifact? Third, dynamical testing. Would the object's path continue to follow pure gravitational prediction, or would subtle deviations betray a hidden propulsion? Each rung of this ladder represented a possible shift from speculation to certainty. For now, the situation remains suspended between astonishment and ambiguity. The world possesses an interstellar visitor, a catalog of verified anomalies, and an absence of conclusive answers. Data integrity must be preserved. Interpretations must withstand rigorous scrutiny, and patience is the only currency with which progress can be bought. Until the solar conjunction ends and 3I Atlas reveals itself again, humanity is left in limbo. It may prove to be an unusual but natural rock wandering the galaxy, or it may represent the first tangible evidence that we are not merely observers in a silent universe, but participants in a larger story whose outlines we are only beginning to glimpse.